that means number of pair of contact surface n is equals to 2. Okay, it transmits power 7.5 kilowatt and a speed running at a speed of 900 RPM. So convert RPM to radians per second by multiplying this with 2 pi and divided by 60 to convert this to second. Now the actual pressure is limited to 0.07 Newton per millimeter square. That is the maximum pressure. Now if the coefficient of friction is 0.25 mu, the symbol that we use is mu, so it's 0.25. Find, first part, the mean radius and phase width of the friction lining, assuming the ratio of the mean radius to the phase width as 4. Then part 2, they ask us to find the outer and the inner radius of the clutch. Okay, so I have a diagram shown here. This will be the friction lining material. So the phase width, okay, the phase width, forget about this, okay? The phase width here is W or B, okay? W or B, the phase width. This is what we need to find, the first thing, okay? So the formula that will be used or applied will be pressure equals to force over area. A, the area of this section here, the area of this, okay? So you can take the length, the circumferential length of this frictional lining material, multiplied by the width. This should be width, okay? W or B. So you have area is equals to 2 pi r, which give you the circumferential length, multiplied by the width, that is this, or the B, okay? So, and we know that this r here is actually the mean radius, okay, the mean radius, because now you are looking at this as an overall. So the r here should be your mean radius. So you take r1 plus r2 divided by 2. So and then this w here, that means this width here can be found by taking the outer radius. That means from the center here to this point here is the outer radius, this point, okay? And then from the center to this point here as the inner radius. So if you want to find the phase width, so you have to take R2 minus R1, or the outer radius minus the inner radius. So the solution B, first thing is, when you take a look at the question, they have already said ratio here. Ratio of the mean radius to the phase width is 4. So you got this equation. So area of friction faces. So you have the W. W is the spring force, okay? Is the actual spring force. Actually, you got this formula based on this, where you have pressure equals to force over area, where this force here is the actual spring force, which is equals to the product of pressure and area. So the area we have already got 2 pi r W. So we just substitute it into this formula here. And then since we know that now this is the width, the phase width here from this, okay? The phase width, this is not the spring force here, it's different. This is the phase width. It's better for me to use B actually. Okay, equals to R over 4 from this. So if you were to substitute this equation here into this original formula that we have here, so we have the spring force given by this. Okay, so R refers to the mean radius. So basically, this is the general formula for the torque, okay? So we have this. Once we substitute the W, which is equals to this, into here, okay? So you get the torque equation. Then you got this. So when you simplify this, you got 0.055 r cubed in terms of the mean radius, where n is 2, pressure is given 0.07 Newton per millimeter square. So the pi and the mu, coefficient of friction, is 0.25. So you get, that is how you got your 0.055 r cubed. This r times this r squared times this r, you got r cubed, yeah? So since power is equals to 2 pi n over 60 times torque, so for the subject, that is the torque, okay, substitute power and speed. Okay, the torque, which is equals to 0.055 r cubed into here, that is this, equals to 60p over 2 pi n. So from this, you'll be able to find out the mean radius 113 and the width of the friction surface to be 28.25 mm when you solve this equation. Okay, so based on the mean radius, actually you can find out your R1 and R2, okay, in the later stage. Okay, that's all. Thank you.